You're welcome to physics class online. Please make sure you hit the subscribe button, like our video, and turn on the notification bell if you have not joined this channel. Please kindly join this channel. Now, in previous classes, we started with a topic where we're talking about measuring instruments. We talk about examples of measuring instruments, and we started from the measurement of length. And in that classes, I talk about the vernier caliper, I talk about the meter rule, we talk about micrometer, screw gauge, we talk about the use of those instruments in measurement of length. And at the same time, I added a video whereby I explain how we can use a vernier caliper to take measurement of a small distance, how we can use the micrometer gauge also to take measurement. So if you want to still watch those videos, you can just go to my description, go to the description, you'll see many links of the videos that I've produced before now. So you can just click on those links and watch those previous videos. But today we want to look into something just to continue in our previous classes. To continue in our class today, we'll be looking at measurement of time, mass, weight, and volume. Now let's go into the class. All right, measurement of time. What is time? The time interval between two events is the difference between the time when the event occurred, especially when the time interval is of the order of minutes or hours. When we're talking about time, a time is just talking about the intervals between events. When there are two events, the interval between the events is what time is all about. And when we are talking about time interval in order of minutes or hours, we use our clock and watches for measurement of time. Everybody have clock at home. You go home, you set the clock, and most of us we have our watch. So even we have watch on our phones and everywhere where we can use to measure the time or to determine the time. As I'm talking now, if you check the time, okay, the time is 9 o'clock. So we use that watch to determine that time. Then for shorter time interval of the order of seconds, we use the stop clock or a stopwatch to measure time. When we get to the laboratory and want to carry out an experiment, like experiment of simple pendulum, when we want to determine time for a body to complete an oscillation, we need an instrument to be able to measure time of that seconds, in the order of seconds, so that we'll be able to record accurately. And that is why we need a device to do that. So examples of instrument to measure time when we're in the lab, or to measure time in order of seconds, we use a stop clock and we use a stop watch. Time is also measured by heartbeat. You see the doctor, they put a stethoscope just to test the heartbeat, and thus is by the heartbeat it counts. There is a count. So that instrument, which is a stethoscope, can also be used to measure the heartbeat. Is also an instrument to determine time. Then we have a sound clock. All these devices will be shown in the next slide. So let's look to the next slide and see. Now, if you check this slide, you are going to see the stopwatch. So that is the stopwatch. So then we have the stop clock, and then we have the sound clock. Those are the instruments. So just for identification, that's why I'm showing you that instrument. Now let's move to the next thing, measurement of mass. Now the mass of a body is the measure of the quantity of matter it contains. So the quantity of matter contained in the body is what mass is all about. And mass is usually measured by comparing it with a standard mass. What do I mean by standard mass? You are talking about mass of a known value. So when we want to determine the mass of an unknown value, then we have to compare it with the mass of a known value, which we call the standard mass. And how do we do this? We do it by using an instrument which is called the beam balance or chemical balance. It is important to know that mass is measured in kilogram. In our previous classes, we said, when we talked about unit and measurement, I said mass is measured in kilogram. All right, let's look at this measuring instrument of mass. You see the chemical balance, you see the beam balance. So that's the beam balance. So we use this beam balance to determine mass, and you have seen the chemical balance also to determine mass of a substance. So let's look at weight. Measurement of weight. Weight of a body is the force acting on the body due to the Earth's gravitational pull on the body. Weight is just the product of mass and gravity. It is the force exerted on the body due to the gravitational pull of the earth on that body. An instrument to determine the weight of a body is the spring balance. So weight is measured in Newton. So if you look at it, what I'm saying in essence is that mass is not the same thing as weight. So don't say mass and weight and mix the two together. There's a difference between mass and weight. Now let's look at this instrument. This is the spring balance. This instrument, if you get to the lab, you'll see this instrument. These are the instruments that we use to measure weight. There's a spring inside. That's why we call it a spring balance. All right, let's look at the difference between mass and weight now. Now I said previously now that mass and weight is not the same. So let's look at this table to quickly run through the differences between mass and weight. Number one, mass is the quantity of matter present in the body, while weight occur due to the force of gravity acting upon the body. Number two, mass is constant. So that what I was saying is that irrespective of the situation, mass of the body is always constant, but weight varies. Why does weight varies? Weight varies because gravity determines the weight of the body, and gravity is not a constant. Gravity changes. As we go high, the gravity reduces. The higher you go, the gravity reduces. So it reduces with altitude. So every location on the surface of the earth does not have the same gravity. So depending on the gravity determines the weight of that object at that particular point in time. Now, another difference is mass is a scalar quantity while weight is a vector quantity. In the next subsequent class, we'll be talking about scalar quantity and vector quantity. So it means mass has magnitude but no direction, but weight has both magnitude and direction. That's what we mean by scalar quantity and vector quantity. Now, the unit of mass is kilogram, while the unit of weight is in Newton. Mass is measured using chemical or beam balance, while weight is measured using spring balance. Now, the principle of mass is applied to obtain mass. Principle of moment is applied to obtain mass. So, the beam balance is designed to work by applying the principle of moment. Why the spring balance is applied to is constructed or designed to apply Hooke's law. In subsequent class, we'll be looking at the principle of moment. We'll be looking at Hooke's law. So the relationship between mass and weight is given as W equals to mg. Weight equals to mass multiplied by the acceleration due to gravity. All right, let's move. Measurement of volume. The volume of a liquid in centimeter cube or mil can be measured by using any of the following. We can use a measuring cylinder, we can use a measuring flask, we can use a pipette, we can use burette, etc. Now, the volume of irregular solid can be determined by using the required formula. For instance, now, if I say determine the volume of irregular solid, give me examples of irregular solid, give me examples of irregular solid. When talking about regular solid, we can say a cube, we can say a cuboid. So those are the examples of regular solid. So if you want to say find the volume of a solid like a cube, you say length times 3, that is length raised to power 3. If it is a cuboid, you say length times breadth times height. So what you do in that aspect is just simply measure the length, measure the height, measure the width of that shape with a meter rule, then use calculations and determine the volume of that substance. So if it is a sphere too, you use the formula of the sphere. If it, whatever shape it is, as long as it's a regular shape, you use the formula of that shape by measuring the dimensions of that shape and using the formula to determine the volume. Then let's look at volume of irregular solid. Now, if we now have irregular solid, solid does not have a definite shape. We cannot call it a cube. We cannot call it whatever. We cannot call it anything. So what we do is that when we have such solid, we determine the volume of such solid by immersing the solid in a container containing a liquid which does not dissolve the solid. That is, you are immersing the substance fully into a container into a content or a liquid that will not dissolve that solid, because once it dissolves the solid, you won't have an accurate volume of that solid. So by the time you dip it into the solid, the change in volume or the volume of the liquid displaced equals to the volume of the solid. Let's look at the next chart and see that illustration. Look at this now. How to determine volume of an irregular solid. You discover that initially the volume of liquid in that container is 60 ml. So by the time they immerse the substance into it, the height of the level of the water increases from 60 ml to 80 ml. So if I now want to determine the volume of that substance, I will just say 80 minus 60, which is equals to 20. So I have already determined the volume of the liquid to be 20 ml by immersing it in a solid. So that's what we are saying. All right. Now, in chemistry laboratory, even in physics laboratory, there are different devices that we use to measure volume. So those are the instruments. Look at that instrument. We have the graduated cylinder. We have the syringe. We have the burette, we have the pipette, and we have the volumetric class. The purpose of this is that you can familiarize and identify some of these apparatus. Now, other instruments that we use for measurement, we have the wattmeter for measuring power, we have speedometer for measuring instantaneous speed, we have hygrometer for measuring relative humidity, we have hydrometer for measuring relative density, we have thermometer for measuring temperature, and then we have the photometer or Sachi disc for measuring depth. I'll be showing you those pictures so that for identification. Look at this. This is the wattmeter. This is the speedometer. If you check the vehicle and your vehicle is driving, or the bike, and you are sitting at the front, you look at the speedometer. That speedometer is measuring the speed of that vehicle at that instant of time, at that particular point in time. Then look at the hygrometer. See the hygrometer now. So to measure the relative humidity, and see the hydrometer. The hydrometer is used for measuring relative density. So let's look at this. You see the thermometer, you see the temperature measured in Fahrenheit and centigrade. Then we have the photometer used to determine or to measure the depth of the sea. We have other instruments of measurement. So see there's the meter rule. This is the voltmeter. Some of you, when you are getting to the lab, you will be, just by watching this video, it will help you familiarize yourself with these pictures. See voltmeter, look at the ammeter, look at the galvanometer. You see A, you see G. That's how we differentiate them. This is the potentiometer. Potentiometer, look at the meter rule, but like there is a string of constantan wire or any wire of material of particular resistivity is connected along the two black points. Then we have the resistance box. Then we have the meter bridge. You see the meter bridge at the jockey. You see the jockey at the middle. All right, that's the meter bridge. Then we have the rheostat. Purpose of this is just to give you an identification, just be able to familiarize yourself with those instruments. Now let's look at degree of uncertainty. Now in physics, no measurement in physics is meaningful unless we can state the degree of uncertainty in that measurement. So at the degree to which the measured value of some quantity is estimated to vary from the true value is known as the degree of uncertainty. If the measurement of a standard should be 5 and you measure 4.95, then the degree of uncertainty is the difference between the measured value and the true value. So every instrument have degree of uncertainty in their measurement. So uncertainty can rise. This uncertainty we are talking about rises from variety of sources. It could include limitations on the precision or accuracy of the measuring instrument or system. It could be as a result of measurement error. It could be as a result of indefinite nature or a phenomenon being measured, or the limit of human knowledge. Alright, uncertainty is often used to describe the degree of accuracy of a measurement. Anytime we're talking about uncertainty, we also use it to describe the degree of accuracy of measurement. Now, every measurement has a high degree of uncertainty because of two factors. There are two factors which are systematic error, and then we have the random error. What are random error? Random error occurs because of the skill of the person that performed the experiment. That is, if the person performed the experiment does not have the required skill, or due to the error of the person, it's called personal error of the person performing the experiment. We call it a random error. But systematic error is the error due to the improper functioning of the instrument. Now, when the instrument is not functioning well, the fault now is not because of the person performing the experiment, but because of the instrument that is having that error. So that's why we call it systematic error. And examples of this systematic error, we have what we call the zero error, and so on and so forth. In subsequent class, we'll be talking about what zero error is all about. I believe you've gained from this video. Please kindly watch over this video, for better and better understanding. Please make sure you like this video, share this video, subscribe to this channel, and turn on the notification bell. And I'll make sure that I'll post some of those previous videos into the description pane. So make sure you just go through and pick my previous classes. Thank you for enjoying this class. You are welcome. God bless you. Bye.